Welcome everyone to This Explainer. Whether you're a classroom educator looking to sharpen your pedagogy or a parent trying to support your child's learning at home, you are absolutely in the right place. Today, we're unlocking the transformational power of visual and physical learning in mathematics. We are talking about a method that takes math from a series of confusing invisible rules and turns it into a deeply logical, tangible experience.
To start us off, I really want you to think about this vital question. Why does math feel like an unsolvable mystery to so many students? I mean, think about how we teach reading. We would literally never teach a young child the letter CAT without ever showing them a picture of a cat, right? That would be completely meaningless. Yet for generations, we've kind of just expected students to understand abstract mathematical symbols like addition signs and complex fractions without ever giving them a physical or visual anchor to show them what those symbols actually mean.
Okay, let's dive into this. Here is our roadmap for solving this over the next few minutes. 1. The abstract math mystery. 2. What is the CPA approach? 3. The 3 stages explained. 4. An interlaced learning system. 5. Mastering the 4 operations. And 6. Why CPA benefits everyone.
Starting with Section 1, the abstract math mystery, where we identify the problem.
You know, the common struggle in math classrooms all over the world is this tendency to just jump straight to numbers and symbols on a whiteboard without building any foundational context first. And this jump, it creates a stark divide in learning. As we can see on the left, we have rote memorization, what educators call instrumental understanding. This is basically when a student memorizes the rules without knowing the reasons. They might know that carrying the 1 gets the right answer, but they have zero idea why. But on the right, that's our actual goal. Relational understanding. This is when a student knows what to do and exactly why it works in the physical world.
Moving right along to Section 2, what is the CPA approach? Let's look at its origins and evolution.
Now, you might have heard of math mastery or the CPA method and just assumed, oh, that's a brand new trend imported straight from East Asia, like Singapore or Shanghai. But actually, its roots go much deeper. The foundations were laid way back in the 1960s by American psychologist Jerome Bruner. He proposed that learning requires scaffolding and is way more effective when it moves from tangible actions to visual representations and finally to abstract symbols. This idea later merged with Benjamin Bloom's 1968 concept of learning for mastery and the UK's 1982 Cockcroft report, which stressed applying math to practical situations. Modern East Asian curriculums brilliantly synthesized all these ideas, which is what we now call teaching for mastery.
And all of that history culminates in the 1-2-3 progression you see right here. Concrete, pictorial, abstract. This straightforward yet absolutely powerful framework is now the primary instructional model driving math curriculums, not just in Asia, but in schools across the UK, Canada, Australia, and New Zealand. All right, Section 3, the 3 stages explained. Let's take a little cognitive journey.
Let's unpack exactly what happens in a student's brain during this process. Stage 1 is the concrete stage, or what Bruner called the inactive mode. This is the doing stage. Students get to interact with tangible manipulatives, things like base 10 blocks, multi-link cubes, or honestly, even just household items like straws or dice. It's such a brilliant low-floor entry point, you know? It's accessible to everyone, and it physically builds muscle memory and a genuine tactile sense of quantity.
Next, let's see how this builds into the second stage, the pictorial stage, or the iconic mode. This is the seeing stage. Once students are comfortable with the physical blocks, they move on to visual representations. They might sketch out the blocks they just used or use structured diagrams like bar models. This is the critical mental bridge. It's what allows students to visualize mathematical structures in their mind's eye without actually needing the physical objects in their hands anymore.
Finally, we arrive at the abstract stage, or the symbolic mode. This is where we use pure notation, numbers, letters, operation signs, the whole shebang. But here is the magic of CPA. Because the student has already done the math physically and seen the math visually, an abstract equation like 2 + 3 = 5 isn't just a collection of arbitrary marks on a page anymore. It carries deep relational meaning.
Which brings us to Section 4, an interlaced learning system, looking beyond just those 3 steps. Now, what's really interesting about this slide is it clears up a bit of a misconception. It's super tempting to think of CPA as a rigid, one-way street where you just check off 3 boxes and you're done. But as education expert Andy Fissarianos points out, it is actually a sophisticated, interlaced learning system. Because let's face it, learning is messy.
It requires constantly moving back and forth between these stages. If a child gets stuck on an abstract number problem, a great teacher doesn't just repeat the numbers louder, they hand the child the physical blocks again to re-anchor their understanding. And this interlaced approach, it's backed by some heavy-hitting psychology. Piaget's theories tell us that returning to concrete tools actually helps manage productive struggle, so students can rebuild their mental schemas. Then you have Vygotsky's theories, which show us how pictorial models act as scaffolds to push students into their next zone of development. And from Zoltan Dien's, we learn the sheer importance of perceptual variability. Basically, that means don't just use wooden blocks. Use beads, use money, use straws. Doing this ensures the student abstracts the core mathematical concept itself, rather than just learning how to play with one specific toy.
Section 5, Mastering the 4 Operations. Let's see CPA actually in action in the classroom.
So how does this actually look in a classroom on a random Tuesday morning? Well, let's explore how the CPA method beautifully models the foundational operations, starting with addition. We can introduce column addition concretely by using bundles of straws to represent tens, and individual straws for ones. Once they totally grasp that, we advance to formal Dean's base 10 blocks, and eventually to flat place value counters. These physical tools map perfectly onto a baseboard to mimic column addition. Students physically combine the groups way before they ever write down a carryover digit.
Subtraction follows a beautifully similar path. We use straws to physically take away ones. Then, when we need to teach that notoriously tricky concept of borrowing or exchanging, we use Dean's blocks. A student physically trades one 10 block for 10 1 blocks. Because they physically execute that exchange themselves, it completely prevents that common early confusion when they eventually move to the abstract written notation.
And this brilliantly illustrates multiplication too. Before expecting a student to just memorize a stacked column multiplication, CPA uses the grid method. A student might literally lay out 2 10s and 3 1s 3 separate times using straws. Visually laying out the grid method physically proves exactly what happens during multiplication, partitioning the 10s and 1s so the child truly understands the mechanics of the math.
Finally, division. Now, division involves 2 really big concepts: sharing and grouping. To teach sharing, you might literally share individual straws equally among a few stuffed toys on a desk. To teach grouping, you physically partition numbers. By connecting the physical sharing of toys and straws directly to the formal short division bus-stop method, a student realizes that the abstract method isn't some weird magic trick, it's just a faster way to write down what they already did with the stuffed animals.
And our final section, Section 6, Why CPA Benefits Everyone. It's truly a universal framework.
We really need to emphasize this. CPA is not just some remedial intervention strategy for struggling students. It's a universal cognitive framework for all learners. For the whole classroom, it creates this deep relational understanding, ditching meaningless rules. For advanced learners, it prioritizes depth over speed. Instead of just calculating an answer quickly, a gifted student is challenged to prove a complex equation through a pictorial bar model. And for educators, it significantly reduces teacher workload. When a curricular has this progression built in, teachers can spend their time on adaptive, in-the-moment teaching, rather than trying to invent new ways to explain abstract concepts from scratch every single day.
I want to leave you with this final provocative thought. If we know for a fact that human beings process knowledge by moving from the physical to the abstract, why would we ever teach math any other way? The CPA approach aligns our classrooms with human nature, transforming students from simple rule followers into logical, flexible, mathematical thinkers. Thank you so much for joining me on this explainer today, and I really hope you're leaving inspired to bring the tangible world into your own math lessons.